Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. Good day everyone and good afternoon. First and foremost, I would like to thank to Encik Sufian Anwar, our today's host, and not forgetting our chairperson, Mrs. Nina Marlini. Me, myself, Rosmaliza binti Cik Ibrahim from SMK Sri Bintang Selatan, Kuala Lumpur. I feel so honored today to present to you my oral presentation entitled Problem-Oriented Project-Based Learning or POPBL through Modular Teaching and Design Thinking Practice. Ladies and gentlemen, the integrated STEM education approaches through chemistry, mathematics and technology design subject using modular teaching method is something new that is to be explored by STEM teachers nowadays. This best practice has been implemented by applying problem-oriented project-based learning (POPBL) through modular teaching and design thinking that inculcates 21st century learning in order to innovate an invaluable marketable product that suit the educational challenge in the Industrial Revolution IR 4.0. Here is the table of contents of my presentation. There are 6 agendas that I'm going to pinpoint, which is the first one is the background as an overview of the practice, while the second one is the scope problem, and the third one is the goal and benefit that is focusing on the efficiency of the best practice that has been implemented, and the fourth is the literature review, that reference of the previous studies that related to the topic, while the fifth one is the results and discussion. It is an evaluation, the assessment that have been done through the best practice implementation. And the last one, we are going to focus on the conclusion, whereby we are going to find out the key points of the overall discussion. Here are some brief introduction regarding the topic. The issues that I'm going to pinpoint is the decline of interest among students to pursue STEM as their selected field, and then becoming their career path is very obvious. Statistically shows that only 90% of the candidate has chosen to enter the science stream. Integrated education, STEM education through a modular teaching in problem-oriented project-based learning have to be implemented in school to narrow the competency gaps among the teachers. Same goes to the students too. This process empower a positive globalization by contributing the teacher's coherent action and student formulation for better understanding of scientific mindset, knowledge and skills. My school is namely SMK Sri Bintang Selatan, Kuala Lumpur. It is located in Cheras, in the heart of Kuala Lumpur city. It consists of 918 students with 83 teachers. This is our team that is consists of one female student, namely Sharifah Aliyah binti Syed Sharin, and also 2 boys, Muhammad Syaril, and also another one boy that is called Manoj. This best practice was implemented in 4 phases. The first phase commenced with an intervention and pilot test where there are 3 science streams from 4 students aged 16 years old were selected as the potential candidates to collaborate with the teacher. These 3 students were then given a briefing by the teachers, and their consents of participation in this project was acquired from their parents. During the second phase, the students attended a modular teaching and learning session that has held by the teacher after school hours. The 3 cooperative and industrious students learned and understand the concept of this project with speed and ease. The scope of the project revolved around the method of the integrated STEM education by implementing significant approach, skills and learning design that suit the students' ability. Applied STEM pedagogy resources also believed in delivering a high impact on the national curriculum, which leads to the excellence, innovative, competitive, resilience, and the students to accept the challenge of the Industrial Revolution 4.0. The students' ability to link the ideas of science and mathematics and apply technology and engineering design can be observed during the group's discussion activities. This therefore demonstrates the POPBL and STEM education program should be promoted to carry out in school. The implementation of a project-oriented and a group activities can help to nurture positive attitudes and interpersonal skills such as teamwork, diligence, perseverance, and creative thinking, as well as presentation skill. The learning design that has been applied consists of a modular design thinking and design thinking. The modular instruction is an alternative instructional design that used to develop instructional material which are based on the needs of students. Students are encouraged to work on various activities such as an interesting and challenging to maintain focus and attention, thereby encouraging independence in study. Another learning design that has been applied in design thinking, the design thinking method, has been proven to improve teaching. It also can promote students' participation in defining the problem they encounter. Design thinking also stresses the imagination, that means generating a lot of ideas. Teachers instruct students to have an open mind to define problems, to create prototypes and hone those prototypes through multiple iterations until they have generated a viable solution. Failure and frustration are natural in part of process. Students learn resilience through the concept of failing forward. According to the recent presentation by Stanford University, the design thinking helps children learn that they have the power to change the world. Moreover, what they can change is now rather than waiting until they are older. The 21st century skill is a new set of skills which is needed to prepare students to survive and work in this digital era. With this model, there are 4 main criteria that needs to be weighed in order to produce a generation which is capable in handling 21st century challenges. The 4 criteria are the digital age literacy, the inventive thinking, the effective communication, and the last one is high productivity. Additionally, to accommodate a unique Malaysian context, another criterion that is a spiritual norm and values which also has been added. The ultimate goal of these projects are focused on knowledge, skills and practices, and so-called a mind setting which leads to improvement of education quality. This process leads to advantages that are attained from the implementation of the best practices. Teaching students to apply knowledge and skills to benefit others or to serve the public good is an exceptionally high impact method to foster these capabilities across the discipline. Here are some literature reviews that we went through for this project. Bybee 2010 and Hochländer Wanowski says that STEM education is focused on improving science and mathematics as isolated discipline. Wang et al. Says that with a little integration and attention given to technology and engineering, the STEM education will become more improving. National Academy of Engineering and National Research Council (NAE and NRC) says that making cross-cutting STEM connection is complex and requires teachers to teach STEM content in deliberate ways so that students understand how STEM knowledge is applied to real-world problems. Currently, cross-cutting connection remains implicit and can be missing altogether. Kay and Honey says that 21st century skill is a digital age literacy which encompasses communication competency, analyzing and interpretation of data, understanding and assessment of models, task management and task prioritization, involvement in problem solving and ensuring well-being and safety. While for Ibrahim and Halim also says that problem-oriented project-based learning, or normally so-called that POPBL, can enable the students to achieve high results in their work. While Yusuf also says that the project that has integrated in POPBL gave hands-on experience and engineering students in solving sustainable related problem. It is not only in terms in technical aspect, but the ability to identify the economic and social aspect of the problem. Here are the figure 1 that illustrates the proposed phase in the conceptual framework for an integrated STEM education. The image presents the block flow of the sequence to be followed by the teachers and students in applying the integration process. Students should be given an intervention to give them a clear picture of the project and how it be implemented successfully. Firstly, briefing session handled by the teacher and the consent participation from the parents are required in order to fulfill the standard operational procedure. Modular teaching and learning sessions are held by the teacher after school hours to cater the students' knowledge have to be related to the project. Accordingly, they are taught modularly in 3 subjects: chemistry, mathematics, and technology design. The knowledge gained from the chemistry in the structure of dry cell were well connected to the steps of calculating the ratio of the electrolytes and the carbon powder that are used to build a dry cell. They are then exposed to 21st century skills and design thinking skills that were essentially to be applied while conducting the innovation. The 21st century skill is a digital age literacy which encompasses communication competency, analyzing and interpretation of data, understanding the assessment of the model, task management, and task prioritization. Finally, the innovation phase takes place. At this phase, the students are also required to design a new artifact. The artifact design, which is formed based on the ideas shared with the team's members, managed to increase the students' inventiveness, and this had a positive effect on high productivity. The illustration in Figure 2 connects the design thinking system to the problem-oriented, project-based learning. Yusuf et al. 2011 found that the project that was integrated in POPBL gave hands-on experience to the engineering students in solving sustainability-related problems, not only in terms of technical aspect, but the ability to identify the economic and social aspect of the problem. The cycle in Figure 2 starts with defining problem, and it is followed by doing research regarding the problem. Imagine, plan, create tests, evaluate, and redesign the prototype, so sharing the results and justifying the solution and refining. This is so important to point out what these component ideas do not always follow the same order. At any stage, students and the teacher can redefine the problem to regenerate a new solution to replace an idea that is not working out. Figure 3 shows the data of participation of STEM students in our school. The total students' participation increases from 3 to 15 within 3 years, while Figure 4 above shows the data of a multi-level students' achievement in competition and challenges. The total number of students' achievement increasing from 3 to 15 within 3 years. This project might be different from the others since we are implementing multiple instructional strategies and skill while doing innovation. The best practice that has implemented through this project assessed the following, which is the STEM education teaches self-efficacy, the students' ability to apply 21st century skill while creating innovation through design thinking and seeking solution to solve problem, and the third one is assessing the students' and teachers' awareness of STEM careers. During the project, we are facing so many obstacles that had to be faced, such as building the students' capacity and motivation towards positive ways in solving problems while doing the project. Students' knowledge was initially too limited. The teachers has worked ever so diligently to cater their knowledge through a modular teaching session. Eventually, their self-motivation has raised to believe in their own capability to complete the phase successfully. Fortunately, they never gave up and trying to keep on exploring with minimal supervision from the teachers. Thus, their inquiry skill developed very well, and the only challenge that we had was to be faced is the lack of raw plant-based biomass source material due to the school's location, which is at the heart of Kuala Lumpur city centre. We had to travel to rural areas to liaise with the contacts in order to obtain the source of palm oil biomass and other plant-based biomass resources from them. We were unlucky since we did not have any innovation grant as financially support. The cost of the innovation had been fully self-funded by the teacher. However, it was not a big problem since the innovation did not require much cost. The school community has also played a very good role in supporting us. They were able to give moral and professional support, such as giving a review and feedback on the product's development, as well as a positive critic for us to improve our innovation. We suggest that the key to preparing STEM teachers to first begin by adapting to their conceptual understanding of an integrated STEM education by teaching key learning theories, pedagogical approaches, and building awareness of research products. And also same goes to research results of the current secondary STEM educational initiative. The initiative should be firmly engaged by the stakeholders to provide professional development experiences for in-service teachers. Teachers could also provide a strong conceptual framework of an integrated STEM approaches and build their confidence in teaching from an integrated STEM approach by attending seminars and workshops. Finally, further research needs to be done on the integrated STEM education so that the effective methodologies can be implemented by teachers in the classroom and further assessment of the strategies that has been proposed in the overall framework. The framework that has been presented just now is a framework that related to integrated STEM education as a new paradigm of instructional practices in facing Industrial Revolution 4.0 that has been proposed above. Actually, is just one of the samples in the best practice that complies with the available methodologies. Nurturing STEM education is the process of producing a productive generation to develop this world, and thus it should be carried out with honor. That's all from me. Thank you.